is number 8. Now let's go on to section 4.3. So, suppose f of x is a function whose derivative is, so as I'm not giving the original function, I'm just giving you the derivative of this function. Right? I don't know if that's sarcastic or not. The tone doesn't really come across. Find the x coordinate.
It makes me think of my organic chemistry professor who goes like, imagine you're a molecule.
Find the x coordinate of each inflection point, if any. Where the exam on Sunday is about the same length as the second exam, but we have some interesting questions already prepared. I'm actually pretty excited. So
we would get our grades like instantly, wouldn't we?
no, some of it will be manually graded because there will be some text box responses, but there's not going to be many. So hopefully the grading is a lot faster. I mean, I don't know what's keeping everyone. I don't know why everyone else is so slow. Like I said, I was slow because I have all this other stuff to do for the course. No one else has to do it. All right. So suppose a function. I didn't give you f of x, but I gave you the derivative f prime, and now you want to find the x coordinate of each inflection point, if any. So in other words, the answer could be there are no inflection points of the original graph. Okay. So yeah, so I'm going to give you a few minutes to actually work on this yourself, and then we'll come back to it. So try to do this. I'm going to give you 6 minutes to do this. You want to do a breakout room? No, we'll just do it a 6-minute one. Although, if you do want to work with one other person, you actually can click on their name and start a private chat with that person. So you can't quite do a breakout room with more than a few people, but if you do just want to talk to one person, like if you have a friend in the class and just want to compare answers, you can start a private chat with that person. Just find their name in the list. So Gentle, if you want to say talk to Gentle Matri, and begins with J. So scroll down to J and you can start a private chat.
To review real quick, the inflection point is where we have the zero of the second derivative, right?
That's right. You want a change in the sign of the second derivative, a change in concavity. Yep.
Thank you.
Alrighty. So, someone want to type some of their answers. So it looks like Georgia's already typed the answer. Her answer, I should say. So Georgia got x equals -4 and x equals +4. Does anyone have another answer? So as usual, we're going to have the I disagree option, and we're going to have the, let's say, the I didn't finish. I know what to do, but I didn't finish.
It is probable that I did some calculations wrong because in things like these, I just suddenly forget how to read and how to count. So.
Well, it doesn't look like anyone else wants to be brave enough and offer their answer. So these will be our choices for the poll. Oh, it looks like someone else is typing. Be -8 and 8, or 0. Oh, that's right. No inflection point. Be -4 and 4 were actually traps. Okay, so let's actually, these are 4 good choices. So in fact, I'll just do A, B, C, D. So those will be our choices, A, B, C, D. So just choose which one is what. Okay, so the vast majority of people actually said, I know what to do, but did not finish. Okay, so that's understandable. I only gave you 6 minutes to like kind of read the problem and then figure out what to do and then actually do the problem, right? It wasn't a whole lot of time. Although I will say, with enough practice, you should be able to do this very fast, right? So let's actually say very quickly. So Charlotte says, to be honest, I'm not sure what to do. I don't know what to do. Okay. And Meiji said, yeah, I assume you're just agreeing to what I just said. So let's actually do a kind of a roadmap for this. There are a few steps to this problem. So what should you actually do first? What was your first general step?
I rewrote the derivative so that it was a product and not a. I mean, I
Okay,
don't
so
know
for
proportion.
what purpose did you rewrite the derivative?
So that I could more easily find the second derivative.
Okay, so we'll just say compute f double prime of x. Okay, so what's the next step after that?
After, okay, so
Let's get someone else to answer that question.
Okay,
So
sorry.
let's say we have compute f double prime of x. What would we do after that to continue solving the problem? Set it equal to 0. Okay, so solve the equation f double prime of x equals 0. All right, so now we have some set of solutions, possibly no solution, right? That's a possibility. What would we do after that? Is every solution you get to this equation automatically an inflection point?
No.
So Angelica, you said no. So what could happen? What do you have to do to check that?
You have to make like a sign chart and then see where the value like changes from positive to negative or like negative to positive. But if the value doesn't change, then that's not an inflection point.
Okay, good. So what Angelica said is completely correct, right? Whatever solutions you get in the second step, they may not be inflection points because you actually do need to get a change in the concavity. So
Yeah, I
now
forgot to do that.
let's actually do these 3 steps then. Okay, so our second derivative, I'm actually going to leave it in the form of the quotient. I'm just going to use quotient rule. Okay, so what do we get? The denominator we know just gets squared, right? So when we square the denominator, it's x squared plus 64, 5 halves squared. So it's just to the 5th power. Okay, then up top we get bottom derivative top minus the top times the derivative of the bottom. The derivative of the bottom is 5 halves x squared plus 64 to the 3 halves, and then times 2x by chain rule. Okay, so now let's actually try to simplify this as much as possible, because I do need to set this equal to 0, so it'd be really nice if I could, if I can actually have this simplified. Okay, so up top, we get x squared plus 64 to the 5 halves. And then on the second term, notice I have a 1/2 and a 2. So those will actually cancel out. And then notice the x and the x will combine to give me x squared. So altogether, that second term actually gives me minus 5x squared times x squared plus 64 to the 3/2 power. All right, now up top, let me continue to factor. Notice every single one of these terms, notice there's a power of x squared plus 64, a power of x squared plus 64, a power of x squared plus 64, right? So I can actually factor that out. I can factor out an x squared plus 64. So what power should I actually factor out up top? I factor out the smallest power. So I need to factor out a 3/2 power. So if I factor out an x squared plus 64 to the 3/2 power, let me just move this up a little bit. What am I left with? The first term would give me x squared plus 64 to the 2/2, right? Because I had 5/2 and now I'm taking out the 3/2. So that's really just x squared plus 64 to the 1 power. And then on the second term, I'd have minus 5x squared. And all together down below, I have x squared plus 64 to the 5th power. Okay, now this is really good because now notice I have a factor of x squared plus 64, a multiplicative factor, and a multiplicative factor here. So I can cancel out those x squared plus 64s. So down below, I get x squared plus 64, 5 minus 3/2. So that's 10/2 minus 3/2. So I get 7/2 there. And then up top, I have an x squared minus 5x squared. So I end up with 64 minus 4x squared, and that is my fully simplified second derivative. Okay, so now this was not technically necessary. You could have just set this whole thing equal to 0 from the very start, and then the denominator cancels out. But at some point, you will be factoring out the x squared plus 64 to the 3/2, right? At some point, you do have to do some algebra. But I have fully simplified it for you. So this is our, it is a good exercise in algebra too. Make sure you're actually pretty good with all the algebra. So that is our fully simplified second derivative. Now we have to solve the equation f double prime of x equals 0. But that turns out to be very easy because all I need really to do is set the numerator equal to 0. And I get -4 or 4. Right, we did all that algebra to make this, so this equation ends up being not very difficult to solve because all the algebra, all the hard algebra we already did. Now we have to verify. Now verify whether these really do give inflection points. All right, so this is a sign chart for a double prime. Again, because we spent that extra minute or two doing the algebra, this sign chart is also going to be very quick and easy because again, right, that algebra made my second derivative very easy to work with. Notice that there are no other extra points I have to put on my sign chart because the denominator is never equal to 0, right? X squared plus 64, that's always positive. So there are no vertical asymptotes or anything like that, right? If this were an x squared minus 64, notice I would have had to include both -8 and +8 on my sign chart, okay? We're looking for the shape of f double prime, or sorry, the sign of f double prime. That tells us about the original function. And then let's also note what is our test point. So I'm going to choose -5, 0, and 5. The very nice thing about our second derivative is it's going to be super easy to test these points. If I actually factor out the 4, I get 16 minus x squared. So f double prime of -5, f double prime of 0, and f double prime of positive 5. A little bit. I just put this all here. Okay, so notice that the denominator of my second derivative, notice it is to the 7/2 power. That's actually a square root, right? The 1/2 tells you a square root, and a square root is always positive. So the denominator is actually always positive. That's very nice and easy. Now for the numerator, -5 gives me 16 minus 25, which is negative, and the 5 gives me the same thing, 16 minus 25. So those two test points give me a negative up top, and the 0 gives me a positive. So altogether, I can say my sign chart gives me negative, positive, negative. So I get concave down, concave up, concave down. So in fact, I can see that there really is a concavity change both at -4 and 4, right? That means I really do have an inflection point at both. So x equals -4 and x equals +4 both give. Questions about that?